Hi, I'm Gary Parker, Director of Engineering inside a new business unit called the New Power Business Unit at Cummins. And I'm here today to talk about Cummins' future direction in the electrified power space. And with that said, we're going to jump right into our slides. Just to kind of share a little bit about Cummins. Certainly, there's a lot of numbers to read on the screen, and I'm not going to plan to read all of those numbers. But a few interesting things. A few years back, we reached a major milestone of building about a million engines a year. And 2 years ago, Cummins reached its 100th anniversary. And I think one of the milestones that is very interesting that'll happen soon is as we're coming close to reaching a point of investing about $1 billion a year in research and technology, and so that certainly is an exciting milestone that is coming up for the business. The next slide, really, I think one of the things that we're directionally tracking towards, looking out at Planet 2050, is one that Cummins is aligned with the Paris Accord and plans that the U.S. has towards achieving a carbon neutral world in both how we see this happening in the facilities that we have, but then also how it needs to happen with the powertrains that we work on as well. And so, through that, we've got a few key initiatives around what we call Planet 2050. And this is a thing where, many think that, hey, man, 2050 is a long way out. But in reality, the work starts now. And so having really good near-term targets is critical to allow us to keep moving on a path towards carbon neutrality. And really through this, we need to have basically a technology portfolio that enables us to accomplish this goal as we keep moving forward. And certainly most are familiar with Cummins as a powertrain with diesel as a primary source of energy. In many cases, even biodiesel with that, as well as natural gas. But Cummins has moved into these other spaces as well, from hybrid electric to battery electric to fuel cell electric. And so we see these technologies as helping to set the stage as we move forward to reach that point of carbon neutrality as we look out towards 2050. And so through that, there's certainly a set of technologies that we would call as core, as critical to helping to deliver to those kinds of initiatives. And certainly each have a significant role to play in this. And certainly on the battery electric components and powertrain sides, that is focused on full electric. And we'll see cases where there are some applications where a battery electric vehicle is the right solution to help solve challenges, in for example, areas of urban areas, maybe even areas where the energy content need is just absolutely perfect for battery electric. And then there are going to be some gaps that'll come into play, and we see fuel cell systems and powertrains really helping with that. One of the things that is very interesting with fuel cells is the fact that its energy density per unit weight is really fantastic. And so those particular applications that have a really high energy demand, and whether that be the amount of time that the asset is put in to the day, or the miles traveled, where that might be, those higher energy density applications are going to be a place where fuel cell technology we could see really taking off. And as a part of that, one of the barriers certainly is infrastructure. And so as a part of that, Cummins has gotten involved in hydrogen production as a part of fuel supply to help to remove this barrier as we kind of move forward. And so that is a place that needs a lot of work in terms of how we proceed forward. And really through that production, we're focusing on green hydrogen production. And so production of hydrogen that would come through renewables. And while we focus on PEM, fuel cell technologies, with respect to powertrain mobile applications, we're pretty deep in solid oxide fuel cells as well. And its focus in and around power generation, stationary power generation for a number of different applications that exists. Moving to the next slide, the key thing is how all of this actually links together. And certainly, we talked about this notion of battery electric vehicle, and we're talking about this fuel cell electric vehicle, and certainly there's a lot of commonality with the components that are pretty central to it as we talk about electric traction and its control systems, and then the various sources of where the energy comes from. Whether it be a hybrid vehicle where the primary fuel could be diesel, could be biodiesel, could be natural gas, a renewable form of natural gas, all the way up through maybe even the hydrogen itself being a form of fuel for an engine. And you got batteries that can grow if you're a fully battery electric vehicle and you have that's your primary source. Then you might have more battery energy on board in a single vehicle. In a fuel cell, you still need a battery, but that battery gets much smaller, and then you have basically the fuel cell taking hydrogen, and then you're going through the chemical processes to eventually get electricity out that then moves the vehicle forward, and you've got onboard hydrogen storage for that. And then, like I said, on the fueling side, hydrogen production is a key thing for at least at the fuel cell side. And so these things coming together is critical, and Cummins is investing heavily in these areas to build forward towards our 2050 goals. In fuels, we continue to stretch out in different ways, from biodiesel and the progress that we've made there to paraphenetic fuels, where we're doing work and research on to improve product output from that. CNG, including things in progress made in renewables, landfill, or biomass areas. Certainly with electric, how you might charge a battery with a variety of different ways that customers might choose to plug in, from pantograph that might come over the top and connect to a bus to give it a quick charge, a quick opportunity charge, to wireless capabilities. And in most all these cases, we're talking about 1 or 2 C rate kinds of charging levels, which, if you think about the sizes of batteries that can be on these commercial vehicles, that's actually a pretty significant amount of power, that we're talking about in terms of what that need might be. And of course, on the far right here, we're talking about hydrogen as a fuel source. Of course, one of its key characteristics is it's abundant, most abundant element in the universe. There's no carbon contained in the fuel at all, and if it's produced in green ways, we think that is quite attractive in terms of where we can end up as we're kind of moving towards those targets out in 2050. And just a little bit about the Cummins hydrogen story. Through the acquisition of Hydrogenics, we brought in over 70 years of experience in 100 countries with customers, with over 2,000 fuel cell installations and over 500 electrolyzer installations, 60 fuel stations, and then New Power itself as a new business that has been building momentum ever since Tom Linebarger said, "Hey, we're going to do this." We're now up and over 800 employees, focusing on the future. In this next slide, really, there's all kinds of influences in terms about the pace that new technology can go, in order to get a proper amount of adoption over time. Certainly, one is the technology has to be ready. It's got to be reliable. It needs to have certain expectations on durability. It needs to reach certain attributes with the product that the customer expects, and so all that's got to be in place. And so, assuming that is all there, next is infrastructure, right? And so the infrastructure's got to be ready. You got to have an ability for the vehicle to come into a station, a depot, home base, whatever that is, and refuel, and refuel in a way that's like prescribed on the previous slide in one of those critical element and areas. And of course, regulations is also a big part of that. Regulations helps us to create a level playing field. Regulations helps us to advance new technologies and bring them forward and bring them into the market as products. And of course, while those first three categories are very interesting, the thing that is super critical is that the financial models surrounding the end user must be there. And so total cost of ownership is really a key thing that needs to happen for the end user for this to be successful. And so this is a view of some of Cummins' early work. Today we are in production in electric school buses, and so that's going well. We're in production today in transit bus as well, and so these are what we call beachhead markets for electrification that we are proceeding in. And certainly you may have heard in the news of Cummins' work in other areas such as pickup and delivery, terminal tractors, and excavators as well. And so I think that the terminal tractor story, for example, I think is a very interesting one where you do have lots of opportunity to recover energy for goods that are perhaps getting maneuvered and positioned from ships to drayage or to rail and things like that. And so this is just a real simple example of just how technology and standards are evolving over time. And so you think about work just in the last 5 years with respect to terminal tractors or yard spotters. We're able to put 3x more energy on board, which has an influence on the vehicle's daily runtime. Moving to higher and higher charging rates with thanks to standards that are improving and helping move that goal along, and certainly other areas on the traction and power side of evolving that to help move and meet more customer needs. And on the fuel cell side, there's a view of different markets that we are continuing to develop hypotheses for, and either proving or disproving these hypotheses on whether they work. And in certain applications, for example, in rail, I think that's a perfect application in technology for something like fuel cells, where you've got further distances to go and travel, and you've got a technology that enables that to happen. And so that's on the powertrain side. You can see some of those example applications there. And on the electrolysis side, so how we go about producing hydrogen, right, is a big thing as well. And so Cummins is stepping in and saying, hey, we'd like to take one of those critical barriers with infrastructure with respect to hydrogen and start making some progress. And so through that, we have really just begun that journey to help knock down some of those barriers. And some might ask, well, how do these different technologies kind of line up, right? And so what Cummins did is kind of shared maybe some critical attributes that speak to how these technologies work, right? So from zero emissions to range to the speed that you can refuel to how much quiet drive you might have. What does it mean for efficiency or route flexibility? What about its renewable capability and maintenance, right? And so you could see that, zero emissions, battery electric and fuel cell electric both definitely meet the requirements. You can get to zero there. In range, you're going to find that the combustion engine does really well. It's one of the most energy dense, power dense technologies in the world, and it's the reason why it's still here. And so battery can't quite get there. It's lesser on the energy density side of things, but fuel cell can. Fuel cells made some great strides and certainly has worked towards closing the gap, and we'll talk about that here in a moment. Fast refueling is very important to our end users, and all would say that the combustion engine today is the standard for that, and no one would disagree with that. And so battery generally will be slower, and so there's physics limitations to that with respect to topics around, for example, with lithium-ion technology and how fast you can fill a battery pack. But a lot of that's relieved going to fuel cell electric in terms of how quickly you can refuel, almost nearly on par with that of the combustion engine. Quiet drive, certainly both battery and fuel cell can be operate at a reduced noise level, and certainly in certain urban areas that is that's an attribute that could be more important. Efficiency wise, combustion engines and fuel cells are about the same. Fuel cell actually gets a little bit of an edge there because of all of the electric conversions actually are quite efficient. It's just the fuel cell, it's that first conversion. In battery electric, you're starting with the energy in the pack, and all of those components are operating in the mid to high 90% in efficiencies typically. Route flexibility, it's really tough to beat the combustion engine, and so that route flexibility is meaning to deploy an asset anywhere and anywhere you want, right? And infrastructure can play a pretty key part of that, and of course, how long those routes are as well. And so you can see that fuel cell will have an advantage over a battery in that case, going forward. But certainly the combustion engine is in fact the benchmark there. Renewable capability, and so that's one that we see quite a bit of an advantage on the battery electric and fuel cell side. We are making renewable headways with topics related to fuels, and so but at the same time you could say the hydrogen is also a fuel as well, and Cummins recently announced some early work in terms of even actually looking at hydrogen as a gas to combust in an engine as well, and so those are areas of current research. Maintenance wise, it's hard to beat battery electric in terms of the simplicity of its design, and you have a fairly lower amount of let's say different fluids and fuels that you'd have to replace, and so therefore general maintenance is less there. But this I think hopefully will give you a picture as we kind of move forward in time about how some of these critical attributes will trade off from the perspective of the end user. The energy and the route flexibility story. This is one where if we look at a few different applications, specifically calling out drayage trucks, regional haul trucks, and line haul trucks. And so drayage are trucks that are running those routes from the port to let's say maybe a business hub. Regional might have similar coverage, but you can imagine if you've got goods and products that are positioned on the outside of an urban area, and you're delivering regionally, but it's regional of a lot of similar stuff, or stuff that's going to a single place. Usually your vehicle miles traveled on drayage and regional are less, and of course in line haul, it's even more of a challenge, because there you're going between cities and between across the nation, for example. And so you can see how, based on the mileage per day, how the various payloads stack up, and you can see how, if you roll down the very bottom, it's very hard to beat diesel today. It's got, like I said, a great energy and power density, and therefore is the benchmark on payload. So if you carry in loads that have high density kinds of payloads, diesel wins there. And certainly, if you got high weight and long travel, it creates a disadvantage in many cases with battery electric vehicles. And fuel cells are right there. If you look at where it comes out relative to diesel and its potential, right? And so it's not too far behind, but there is some level of impact in terms of how payload needs to be thought. Again, depending upon whether or not product is cubing out or weighing out in the day. So with that said, I hope that was informative. Cummins, we've one last thing to say is we've been around 100 years plus. We're building out this notion of a powertrain of choice portfolio. We're building up capabilities across the applications to provide good value to the end user. We're in it to scale proper so that we can provide the best global impact to the world. And because we've been around 100, we'll plan to be around plenty more years to help us advance towards that goal of 2050. And the billions we've invested in our support network will be a significant part of our business in terms of how we move forward with these innovations. And with that said, I thank you very much for your time.